Hello, my name is Christian Ford,
I'm Gary Garcia.
and today we're going to explain to you guys a physics problem. And so pretty much what happened was, it was January 4th, and an automobile accident occurred between Ms. Schmidt and Mr. Ellis. They were driving on FM 1103, and they met at the intersection of FM 1103 and Main Street. And so what happened was, Ms. Schmidt did not slow down at her green light, and Mr. Ellis did not stop at the flashing red light, and there was an accident, and an accident occurred. And so we're gonna get down to it and see just exactly who was at fault in this accident, and see if Ms. Schmidt not slowing down was the problem, or if Mr. Ellis not stopping at his flashing red light was the problem.
We found the coefficient of the car, which was 0.76923, and then we took that and we took 70% of it, which gave us the coefficient of friction of the truck.
Because the truck tires is only 70% of the car tires friction, so that's why we did the 70% thing. That way, once we found the car's coefficient of friction, we basically found the truck's coefficient of friction. Alright, so to find our velocity before, first we had to find our acceleration, and to find our acceleration we used our coefficient of friction, we used the force that it gave us, and we used the equation F equals car over ma, and that's how we got our acceleration. And then we did the exact same thing for the truck. Right after that, we did, to find the actual velocity, we plugged in the factors x equals 13, because in the question it tells us that the car was 13 meters away from the stoplight to where the collision was, so we get x equals 13 for that. And then we used our acceleration that we got for the car, which was 7.55, and we plugged that into one of our kinematic equations, getting the velocity for the car to be approximately 14 meters per second. And then we did the exact same thing with the truck. We just used our force that it gave us for the truck, used our coefficient of friction that we got for the truck, and we got our acceleration to be 5.29. We then plugged that into our kinematic equation, where we used x equals 11, and we also used x equals 14. We found both of those velocities, one for x equals 11 and then one for x equals 14. Then after that, we used both velocities, added them up, and then divided it by 2 to find an average velocity, in which we got approximately 11.4. And that's how we got our velocities before.
Alright, so we found the velocity for after the crash, and so for the car, or for both of them, we did force times distance equals 1/2 mass times velocity of the final squared minus 1/2 mass times velocity of the initial squared. And we got that, and we found the final velocity of our car, and we did the same thing to find the final velocity of our truck. In our opinion, Mr. Ellis was at fault, because in the state of Texas, you have to stop at a flashing red light. You have to treat it as if it was a stop sign, and that's like the Texas posted law.
So technically, Mr. Ellis would be at fault, because if he would have stopped at the red light and treated it like a stop sign, like he should have, then that would have prevented the crash in his whole. So yeah, Mr. Ellis was at fault. Ms. Schmidt, it wasn't your fault. You didn't goof up. Good stuff. You did a good job. You're a good driver. That wasn't your fault. So yeah.